Hello students, welcome to my YouTube channel UPSU Technical Center once again. Today's subject is power electronics and topic is chopper. And last class I have discussed the control strategies. This is part 2 of control strategies. Today I will discuss current limit control CLC and it will be number 2. Last class I have discussed time ratio control, that was number 1. Here our output voltage variation, that is the on off positions of the switches, is controlled by the limit of the variation of the load current from I0 min to I0 max. Here suppose this is our load current curve. This is I0 with respect to time t, and here this is our I0 min, and this is our I0 max. So there is the variation between these two limits, and between this limit, that means the variations of the load current from this minimum value to the maximum value, we get the output voltage. In single sentence we say when current vary from I0 minimum to the I0 maximum, then we get the output voltages, and when the current decreases from I0 max to I0 minimum, then there will be no output voltages. So that means the variation in the output voltage at the load side will be controlled by the variations of the limit of the load current from I0 min to I0 max. Okay, so here I will draw the output voltage, that is V0 with respect to time. Okay, if the lecture is profitable, kindly give a like, and if the lecture is profitable as well as knowledgeable to you all of the students, so kindly share to your friends, and those are new, kindly subscribe this channel. Okay, so here it will vary from I0 min to I0 max. So current will rise. That means it will rise from low value to high value. So we can say it will increase in such a way. When current will increase from this, here we will get the output at the load side, and this voltage will be a rectangular pulse. Okay, and this will be the rectangular pulse over here. Okay, so here we'll get the output voltages, and when it will increases from I0 min to I0 max, then we'll get the pulses. Afterwards, when the current will decrease from I0 max to I0 min, then the voltage will be zero. There will be switches off and there will be no voltages. Similarly, when current will rise again from I0 min to I0 max, then the voltage will increase once again, and here you will get the pulses, that is the rectangular pulse as before. Their shape will be same as before. As per my drawing, there will be some changes in dimension. Kindly consider these things. So this will be the rectangular pulses, and both are same size. Their dimension will be same. Similarly, current will decrease once again. That will from I max to I min, I0 max to I min, and this pulse will repeat it to the next way. So current decreases from I0 to I0 max to I0 min, then there will be no voltage. When current will rises from I0 min to I0 max, there will be voltages. So this way we'll get the card. Okay. So that will be continue for the next way. So I will just draw this and you know the pattern. Okay. So here we'll get the this pulses over here, and this will be the output voltages. Now when we'll get the output voltages, that means when we'll get this, so here will be here will be the sorry there will be the last pulses, and next one it will increase, because here it will rise. So in this way we will get the variations. So now what will be the actual t on and t off period? Look at here, in this period between this here to here, it will be the T on period. So T on period will be in between when the current will increasing from I0 min to I0 max. So it will be T on period. So T on period. And afterwards for this period here, this is the T off period. And between this T off period, current will be decreased, and this will be T off period. So summations of the T on and T off, that will give you the total cycle, that will give you the time period T. Here it will be same as here also, it will be T as before, and this will be the time period. And here something you have to keep in your mind, that means the changing of this current from I0 min to I0 max, that will give you the ripple, that is I0 ripple. I0 ripple I0 ripple equal to I0 max minus I0 min. Okay, so I want I want to reduce ripple. That means you want to reduce this value. That means the switching frequency, that is the frequency of switch, will high. So if we want to get less ripple, that is the value of this I0 max minus I0 min value, we want to get a reduced value. That means we want to get the less ripple, then the switching frequency will be more, and if we increase the switching frequency, it will create loss. It will create loss. Which losses? Switching loss. SWIT, switching frequency loss, and this is not desirable for this type of operation. So really we do not want this. We especially for the pulse width modulation, I have already discussed in the previous class, because at the time of TRC, time ratio control, there will be two types of control strategies. One is variable frequency, another is the constant frequency. Constant frequency, that means the pulse width modulation, and pulse width modulations was better compared to the variable frequency, that is the frequency modulations, as I have discussed. And now compared to the control strategies of the current limit control with the time ratio control time ratio control and the current limit control, time ratio control is better, but PWM specific in the time ratio control is preferred to the current limit control due to this. Another reasons are also discussed later. So here what actually happen, when the current will increases, then we'll get the input voltage. When the current reaches to the I0 max, there will be no chance to increase the current level, then the voltage will be zero, reduced to zero. When the current decreases, then there will be no voltage. When the current come to the limit I0 min, then there will be no way to increase, no way to reduce this value, to reduce from this value to any another value, because this is the ultimate drop, ultimate limit of minimum current. Then it will again rise, that means then we will get the output voltage. So in such a way, or in such a fashion, we'll get the control of the output voltages of the DC chopper. Okay, so this is the one disadvantages that will create the switching losses, as well as for this the current limit control strategy, we want to get feedback loop is there, triggering circuit is there. It is very much important for this type of, and so this control strategies is complex. That means it requires feedback circuits, it requires the triggering circuits. So this will create the complexity, but compared to the PWM it is far better. Okay, so this is for the CLC control systems. If any questions, any doubt, kindly write in the comment sections, and your comments is very much encouraging for me. Thank you very much for today's class. Thank you very much once again.